So today we are going to solve 3 sum. This is a very famous question. It's a follow up to the question 2 sum. 2 sum is fairly easy question, so not going to make a video on it, but definitely going to make a video on to the follow ups like 3 sum, 4 sum and k sums, right? So in order to solve the k sum problem, one of the ways to reach there is to build an intuition for the smaller easier level problems like 2 sum and 3 sum. So today I'm going to do 3 sum. This question has been asked in all big tech companies. You can see the number of companies that have asked this question. I'm going to use the 2-pointer approach for this question, and I'm going to tell you the thought process or the observation uh, I gained while solving this problem. So jumping directly to the question. So question is fairly simple. It says that you are given an integer and a nums. Return all the triplets, nums of I, nums of j, nums of k, a list of these three, such that the indexes are not equal and the sum of all these numbers in that list is equal to 0, right? So basically it's saying that you want to create answer as a list of answers, basically, where all the numbers, right, all the numbers should result in 0, but it should not contain duplicate. So the valid answer for these two scenarios is this. So this is what 3 sum says. Notice that the solution must not contain duplicate triplets. So it should not contain duplicate triplets. This is one of the catch here, right? Okay, so just for an example, so the numbers here are -1 0 1 2 -1 4. You want to create triplets. So one of the triplet for that will satisfy the condition equal to 0 is this number -1 0 1. Then 0 1 -1 is also there, 0 1 -1 is also there, right? And then -1 -1 and 2 is also there. But if you create a triplet out of these three, you will see that it contains duplicate numbers, right? These are essentially, if I sort it, it will always be -1 0 and 1, right? So we only want to include one such result in our answer. Okay, so now only I have given you a hint, right? For understanding that these a number is duplicate, I have sorted it, right? So this is one cool observation here that has already been given, right? Second thing is, I want to create set of triplets, right? If I place one pointer here, one pointer here, one pointer here, I move these 2 pointer and iterate over for each pointer, it would be 3 nested loops, which would result in O of n square, O of n cube, right? I want it to reduce it to a better time complexity, let's say O of n square. Okay. O of n square now doesn't seems to be too bad, right? If we are considering 3 pointers. So one such cool observation here is, first I will sort my numbers. Why sorting will help is because I will know sorting basically. Okay, so how sorting will help? From the binary search series, you have observed that when I sort, the meaning of sorting is when I place 2 pointers, right, in binary search. How do I decide whether to move this pointer or this pointer? Basically, when I compare it with a middle, right? If my target is, let's say, less than the middle, then I want to search in this space because this space is the one that contains number that is less than middle. Similarly, when I sort this set of numbers, right? When I sort this set of number, I want to know where I want to move next. How will I decide that? The question says it, right? You want the summation of 3 numbers which will be equal to 0. Let's say if it is less than 0, if my summation is less than 0, which number I should now choose, right? So if it is less than 0, then I want a number that is more, that when I add it up it becomes more. So I'll move this pointer maybe, right, to the right side, because this side will contain, the right side will contain greater numbers compared to the left side. Okay, fine. Okay, so going ahead with the example, I'll just try to sort it. Okay, so the sorting would give me -1 -1 0 1 2 and here -4, right? Okay, now I have 3 pointers, right? 1, 2 and 3. Okay, so I'll have 3 pointer and I'll place 1 pointer as a static and I'll just move 2 pointers. I'll sum these 3 and I'll find out if it is less than equal to 0, less than 0, if it is greater than 0, or if it is equal to 0. If it is equal to 0, I simply want to add these three numbers to my result array. But if it is less than 0, that means these three numbers are, when doing a sum, are less. So I want to have a greater number. When I sort an array, the right side will always have the greater number. The left side will comparatively have a lesser number. So that is my hint, right? If it is less than, I want to move this left pointer to this side. If it is greater, then I want to move the right pointer to the left side to find a lesser number. This is the trick here. This is the question. So what I will do is, I'll place 1 pointer here, I'll move this thing to here, and I'll keep on summing them unless and until they become 0, and I somehow make the condition left less than right was false, right? So that left surpasses the right pointer. Then I'll move the static pointer, the constant pointer, to this side. Similarly, then again I'll place these 3 pointers here, right? And I'll compare these two things and I'll add to the result. Again I'll do the same, unless and until my first pointer, the ith pointer, reaches to n, right? Okay, so the second condition here was that it should not contain duplicate. If I sort it, can I say that if I am at this point, if I check a previous number, I will, if a duplicate exists, I will notice it, or I will have it? Yes. So if that condition arises, what I have to do? I don't have to do the computation for this number, right? I just can move the left pointer to this side. Okay, cool, fine. Another thing is, why I only want to move left pointer to the right side, why not to the right pointer to the left side? If I see a duplicate, right? If I see these two numbers duplicate, basically I can do that, but it's not required. Only moving the left pointer check for duplicate is required. You can add the condition in for the right side as well, but it will be not required, because already, let's say I am at this point, it will always check for this two also, if my left pointer is here and if my right pointer is here. Okay, fine. So these are the observation in order to solve this question. Whenever there is a duplicate check happens, one of the naive way of duplicate is always a sort and check adjacent elements. So keep a note of that. Okay. Going back to the solution. Yeah. So the solution is, we can do a 3 sum using 2 sum actually. Right, this. So basically what I'm doing is, like I said, I'll keep one pointer I equal to 0, right? And I'll move it to the last element. Right? I'll check the two previous numbers, if they should not be equal to 0. Then I'll do the 2 sum 2 approach, where my left side will be I plus 1, my right side would be the last element of the array. I'll compare them, I'll sum them. If my sum is equal, I'll add it to the result. If my sum is lesser, I'll increment the left pointer. If my sum is greater, I'll decrement the right pointer. And if again I find a duplicate, I'll just increment the left pointer, right? So some observation here. Sorting always assists us in a 2-pointer approach. Okay, this is very important. Sorting always assists us in a 2-pointer approach. Check if iterations can be skipped. So this observation comes from a question, right? So we should always check if an iteration can be skipped, right? A cool pattern for 3-pointer is, I can loop around from I to n, then I can have another loop from left to right, where left is j plus 1 and right is the length k. I can have my business logic or my whatever logic, right? And this is how, if you see a pattern, right, like you can have 3-pointer, these two has to move from here to here, you will have condition like less than, greater than, and then this comes again here, this moves to the next side, this moves to the next side, and this moves to the, this stays basically mostly. So if you see a pattern like this, then this is your algorithm, good to go algorithm, right? I just add a sort here also. So let me add a sort first. Okay, that's it for today's video. Now I'm going to analyze the four sum question and the k sum questions. uh, Please be connected to my videos and share your love by liking, subscribing my channel. If you have any question you want to ask, you can add it to the comment section. Thank you.